Hello again. We are covering definition number 2 of trig functions, which deals with right triangle trigonometry. So take notes. 2.1, definition 2. Right triangle trigonometry. If you've done any trig in a previous math class, this actually might be the one that's more familiar to you. Right triangle trig. So this definition states that if triangle ABC is a right triangle with C equal to 90 degrees, right triangle, okay, then the six trig functions are defined as follows. Okay, so let's go ahead and draw a right triangle here. So you have a visual of what we are talking about here. A, B, and C is the 90-degree angle. And then this here is the hypotenuse. Okay, and if we focus on angle A, so if we're focusing on this angle here, then this side here is opposite angle A, and this side over here is next to it, adjacent. Okay, so we're going to call this opposite. This is opposite angle A, and this one is next to it, adjacent angle A. All right, and so maybe you learned this, SOH CAH TOA, and this here is supposed to help students remember the three trig functions: sine, S for sine, C for cosine, and T for tangent, in terms of the right triangle. So here, the O, the H, the A, the H, the O, the A, those all represent one of the three sides of the right triangle. O being opposite the angle, A being adjacent to the angle, and H being the hypotenuse. So here's O, that's opposite, that's H, hypotenuse, A, adjacent, H, hypotenuse, O, opposite, A, adjacent. Okay, and so you can come up with the 6 trig functions using those ratios. So let's start with sine. So sine of A, in this case, would be opposite, according to this here, SOH CAH TOA, opposite over hypotenuse. So opposite over hypotenuse. Cosine A, according to this here, cosine is adjacent over hypotenuse. So let's write that down, adjacent over hypotenuse. And then tangent A, according to this, is opposite over adjacent. Okay, and then we can, if we have these 3, we can get the other 3 by the reciprocal. Okay, so cosecant is hypotenuse over opposite. That is just the reciprocal of this. Secant will be the reciprocal of cosine, so that would be hypotenuse over adjacent. And cotangent will be the reciprocal of tangent, so that would be adjacent over opposite. Okay, so if you're given a right triangle, you should be able to find all 6 trig functions if you're given enough information, like 2 sides. Okay. All right, so for example, suppose that you have this right triangle, and suppose that this is 5 and this is 7, and you're asked to find all 6 trig functions. Okay, so if we're going to use this definition of the right triangle for the trig function SOH CAH TOA, these here, then I need to find all 3 sides. Okay, we have this side and this side. We have a right triangle, so I could find the hypotenuse using Pythagorean theorem. So c squared equals 5 squared plus 7 squared. C squared equals 25 plus 49. So c squared equals, let me move this up, 74. So c equals the square root of 74. Okay, so here this side is the square root of 74. And now I can SOH CAH TOA. So then that means sine. Oh, here, let's pick an angle. You know what? I'm going to pick this one over here. Find all 6 trig functions of theta. Okay, so I'm going to pick that one up there now. Okay, so, but these ratios here still apply. So if I'm talking about this angle, the sine is still going to be the opposite side. So opposite this angle would be 5. Let me write it down first. Opposite over hypotenuse. And so that would be 5 over square root 74. If you rationalize the denominator, you have to multiply by square root 74. And that will give you 5 square root 74 over 74. Cosine theta is adjacent over hypotenuse. So here, the adjacent side is 7. Hypotenuse is square root 74. So let me write it down first. Adjacent over hypotenuse. So that would be 7 over square root 74. Rationalize the denominator. Let's multiply by square root 74 over square root 74. And we get 7 times square root 74 over 74. And then tangent theta. Tangent theta is opposite over adjacent. Opposite over adjacent. And so that will be 5 over 7. Okay, so we have sine, cosine, and tangent. Once you have those 3, you can easily come up with the other 3. Cosecant theta will be the reciprocal. So it's going to be square root 74 over 5. I'm using this here, the unrationalized answer. Secant theta will be, again, I'm going to use this one here, the unrationalized answer, which is going to be square root 74 over 7. And cotangent theta will be 7 over 5. Okay? All right, let's look at a little more complex of a drawing, but it's not that much more difficult. It's just being able to read the drawing carefully. Okay, so let's take a look at this one. Suppose we have this drawing. Here's your right triangle. Let's suppose that you also have this other triangle. Okay, suppose this is A, B, C, and D. Okay, and let's suppose that this is 3, 3, 4, 5 triangle. Okay, and suppose this is 2, and this is square root 41. Okay. Okay, so what we actually have here are two right triangles. Okay, and then let's go ahead and focus on some angles here. Suppose that theta is here, and this one up here is, I can't quite draw it here. Looks like this. Okay, anyway, this angle is phi. So this one is the Greek letter theta. And then this one over here looks like this, almost looks like the null set, is phi. Okay, suppose that you have to find A, find sine theta, B, cosecant phi, cosine A, and tangent of angle ABC. All right. Okay, so what we actually have here are two right triangles. So I'm going to go ahead and draw them down here. So we have the big triangle ABC, in which case this is square root 41, and this is 4, and down here is 3 plus 2, which is 5. Because it's all of this, this is 3 plus 2 is 5. Okay, so we have this triangle, and then we have this smaller one, also a right triangle. Okay, so let me draw that. And this is theta, this is phi, this is 3, 4, 5. And this is D, C, and B. All right, so let's go ahead and take a look. Sine theta. So let's do that one first. Sine theta. All right, so theta is over here. Sine is opposite over hypotenuse. So if we will take a look at theta, opposite over hypotenuse, 4 over 5. All right, let's do B. Cosecant of phi. All right, so cosecant is the reciprocal of sine, so that's going to be hypotenuse over opposite. So here is phi. So hypotenuse is 5. Opposite is 3. Okay. Letter C, cosine A. Cosine of A, cosine is adjacent over hypotenuse. So here's A, adjacent is 5, hypotenuse is square root 41. And then D, tangent of angle ABC. ABC. Okay, so tangent of that would be this angle. Okay, so this angle right over here, angle ABC, and we want the tangent. Tangent is opposite over adjacent. So here's the angle. Opposite would be 5, adjacent would be 4. Okay. So again, if you get more complicated looking drawing like this one, don't retreat. It's not as tricky as it seems. Just break it up into two drawings, one with the big right triangle and one with the smaller right triangle. Okay. All right. Okay. Let's take a look at this next example. So triangle ABC is a right triangle with C equal 90 degrees if side A, so we use lowercase, remember lowercase for the sides, uppercase for the angles, so lowercase a. So side A equals 12 and side C equals 15. Find the 6 trig functions of uppercase A. So that's angle A. Alright, so let's go ahead and draw this. They said C is the 90-degree angle. Okay? So I'm just going to call this one A and B. And let's see, what else do we know? Side A is 12, and side A is always opposite A, so this is 12. C is 15, so that's opposite angle C is 15. So now we have to find the missing side. And then once we have this missing side, then we can come up with all 6 trig functions. Okay? Alright, so C squared equals, I guess we'll call it B squared plus 12 squared. 225 equals B squared plus 144. Subtract 144 on both sides. Okay, and we get 81 equals B squared, so B equals 9. Okay, so this side is 9. Okay, now that we have all 3 sides, I can find all 6 trig functions. Okay, and here's angle A. Okay, so this is the angle we're dealing with. Alright, so let's do sine A. Sine is opposite over hypotenuse. So opposite A is 12, hypotenuse is 15. Cosine A is adjacent over hypotenuse. So next to A is 9 over 15. I suppose I could reduce these. 4 and 5. 3 and 5. Okay. And then tangent A is opposite over adjacent. Opposite is 12, adjacent is 9. Okay? And then once we have these 3, we can get the other 3 by the reciprocal. So cosecant. Cosecant A, 5 over 4. Secant A, 5 over 3. Cotangent A, 3 over 4. Okay? Okay. Okay, so a little theorem here about cofunctions. What are cofunctions? So first, before I bring up the theorem, cofunctions. Okay, so turns out sine and cosine are cofunctions. Tangent and cotangent are cofunctions. Secant and cosecant are cofunctions. Okay, and this is important to know because we have this cofunction theorem, which is pretty interesting. So it states that a trig function of an angle is always equal to the cofunction of the complement. Remember, two angles are complementary if they add up to 90 degrees. Okay, so cofunction of the complement. Okay, so let me give you an example so it makes a little more sense to you. So if I have sine of 40 degrees, we don't have that one memorized, but it turns out that one, sine of 40 degrees, is going to be exactly the same as its cofunction. So if we have sine, the cofunction is cosine of its complement. So if we have 40 plus what makes 90? 50. Okay, 50 is the complement of 40. Okay, if we have secant of 60 degrees, then that will be equal to the cofunction. So if we have secant, the cofunction will be cosecant. And if we have 60, the complement will be 30. 60 and 30 is 90. Okay, and if we have tangent 70 degrees, then the cofunction is cotangent of the complement. 70 plus what is 90? 70 plus 20. Okay, so that's kind of an interesting theorem there. Okay, so see if you can fill in the blank here. So try these. Fill in the blank. All right, so suppose that I have sine of what equals cosine 60, and then go ahead and hit the pause button when I have all three of these written down. Okay, tangent 65 degrees is equal to the cotangent of what? And then letter C, secant x is equal to cosecant of what? Okay, so go ahead and hit the pause button, give these three a try, and then check back to see if you have the same answers. Okay, so let's go ahead and fill in these blanks. So first of all, clearly these are cofunctions, sine and cosine, tangent and cotangent, secant and cosecant. So all we need to do here is find the complements of these. So if I have 60 here, then I would need 30 over here. Okay? If I have 65 over here, then I would need 25 over here to make 90. 60 and 30 is 90. 65 and 25 makes 90. Alright, so if I have x here, I need something here to make 90. Okay, so it's going to be whatever 90 minus x is. Okay, so that's what you should have gotten here. Okay. Alright, so that's it for part one. Part two, I am going to go over some of those special right triangles that we talked about, the 30, 60, 90, the 45, 45, 90. So I'm going to talk about that, and we're going to take a look at those special triangles, and we're going to look at what the sine, cosine, and tangents are of those. Okay? Alright, again, if you have any questions, make sure you email me or you text me. Please keep up with the homework.